Hello, this is the luckiest maths teacher in the world. Today we look at two more index laws, the power of a power law and the zero index law. So I'll start with power of a power. So what does that mean? Well, that's when you have something like this. You have a number raised to a power and then you raise it to another power. So you can read this as 3 to the power of 4 squared. So we're raising 3 to the power of 4, getting our answer, and then raising that to the power of 2. Now you probably know by now that when you raise something to the power of 2, as we've done here, that's the same as multiplying the thing by itself. So 16 squared is 16 times 16, 5 squared is 5 times 5, so 3 to the power of 4 squared is 3 to the power of 4 times by itself, 3 to the power of 4. Now you know from a previous video that when we have something like this, when we're multiplying bases, we just add the powers. We keep the same base. So in this case, it will be 3 to the power of 4 plus 4, which is 8. So if we were to do something like 3 to the power of 4 to the power of 3, remember now cubing something is the same as multiplying by itself 3 times. So I multiply 3 to the power of 4 by itself 3 times. But using the same index law that I just spoke of, that we learned last time, I can simplify this. So I keep the same base and I add the powers, 4 plus 4 plus 4. I just add them together. And of course, 4 plus 4 plus 4 is equal to 12. So this is 3 to the power of 12. Now what I hope you notice from these examples is that when we're, say, raising 3 to the power of 4 to another power, we're adding 4 to itself this many times. So in the first one, we added 4 twice. In this one, we added 4 3 times. Of course, when you add something to itself multiple times, that's precisely what multiplication is. Adding 4 to itself is the same as multiplying it by 2. Adding, well, anything to itself 3 times, adding something together 3 times is the same as multiplying by 3. So what we've done in each case is we've actually just taken this number and multiplied by the other number, and that becomes the power. So if I wanted to do, say, 3 to the power of 4 to the power of 9, instead of writing it out in expanded form like this, there's a quick way to do it. It would just be 3 to the power of 4 plus 4 plus 4, etc., 9 times. So the quick way, 3 to the power of 4 times 9. We're just multiplying the two powers together. And that's, of course, 3 to the power of 36. Okay, so I'm just going to move to a new slide. Please copy this down if you need. So I've put the index law in words up here. So this is the third one that we've learned. When you raise a power to a power, you keep the same base and just multiply the two powers together. So when you have something like 4 squared to the power of 7, it's just 4 to the power of 2 times 7, which is 14. If you have 3 to the power of 2 raised to the power of 5, that is just 3 to the power of 2 times 5, which is 10. Let's say you had something like 2 to the power of 2 to the power of 3, and then you wanted to raise that to the power of 4. That would just be 2 to the power of 2 times 3 times 4, which is 2 to the power of 24. Remember, all of these answers that I'm giving are index form. Sometimes you'll be asked to give things in index form. So a generic way to write this law is if you have a to the power of b and you raise that to the power of c, that's the same as keep the base, multiply the powers together. It really is as easy as that. Okay, so now we're going to move on to the next index law. The last one you'll have to know this year, which is the zero index. Okay, so what do I mean when I'm talking zero index? Well, remember, index is the same as power or exponent. What I'm talking about is when I raise some number to the power of 0. Now, it's very natural that you would think that that would equal 0. You'd probably think, okay, 2 to the power of 0, that's got to be 0. 4 to the power of 0, that's got to be 0. But that's actually not true, and I'll tell you why. So let's consider something like this. 2 to the power of 4 divided by 2 to the power of 4. So from previous lesson, remember that when we're dividing bases, so we've got the same base here, we keep the base and we subtract the powers. So 2 to the power of 4 divide 2 to the power of 4 equals 2 to the power of 0, because 4 minus 4 is 0. But what I want you to know is that 2 to the power of 4 is actually just 16. So this is the same as 16 divides 16. But hang on, anything divided by itself is 1. 16 divided by itself is 1. So the only way that this statement here can be true is if 2 to the power of 0 equals 1. But hey, I could have chosen any, positive whole number for this. I could have chosen 3 to the power of 4, and I would have got the same result. If I do 3 to the power of 4 divide 3 to the power of 4, I know that that's equal to 3 to the power of 0, but I know that it's also equal to 81 divided by 81, which is 1. It doesn't matter whether this number, the base, is 4, 5, 6, whatever. So, by this logic, any positive whole number, when you raise it to the power of 0, it doesn't equal 0, it equals 1. So I've written it for you in blue up there. Any positive whole number when raised to the power of 0 equals 1. So a generic way to write this would just be x to the power of 0 equals 1. But I need to tell you something. I did actually lie a little bit, and I'm really sorry. And I'm sure you guys are so smart you would have picked it up. So what I sort of lied about, I said before that anything divided by itself equals 1. And we know that that's it's true almost all the time. 16 divided 16 is 1. 100 divided 100 is 1. 50 divided by 50 is 1. But actually, 0 divided by 0 does not equal 1. In fact, it's undefined. It doesn't have a value. That's the same when you divide anything by 0. Because when you're dividing something by 0, let's say you want to divide 4 by 0, you're saying what number do you times by 0 to get 4? And there's no number you can multiply by 0 to get 4. So make sure that you understand this. You can't divide anything by 0. 0 divided by 4 or any other number that's not 0, that's fine. That just equals 0. But 4 divided by 0, that is undefined. So when you divide 0 by itself, it's undefined. It doesn't equal 1. So for that reason, x can't equal 0 in this thing here. So 0 to the power of 0 does not equal 1, because that would be 0 to the power of 4 divided 0 to the power of 4, which is 0 divided 0. So because you can't have 0 divided by 0, you can't have 0 to the power of 0. So that's why here we're just going to look this year at positive whole numbers. So this will work for any number that is more than 0, whether it be a half or it be 5, 6, 270. We're only going to look at positive whole numbers, however. So any positive whole number when raised to the power of 0 doesn't equal 0, it equals 1. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.